Hey guys, and welcome to this video on algorithm analysis. So in this video, we want to determine a function that we're going to call f of n that describes the number of times the statement y equals y plus 1 is executed in terms of n. Then we're going to determine a big O notation for the function f of n. And I have some pseudocode in the red rectangle here that we're going to use to describe the number of times the statement y equals y plus 1 is executed. So first thing we're going to do is assume that there is some arbitrary input for our variable n. Next, we have our I, j, and y integer variables where we set y equal to 0. And after that, we have our outer for loop that runs from I equals 1, and it's going to run while I is less than or equal to n times n, and then I is going to increment by 1 each time by the statement I plus plus. And within that for loop, we have another for loop that runs from j equals 1, and it's going to run while j is less than or equal to I times I, or I cubed, and then j is going to increment by 1 each time. And within that for loop, we have our statement y equals y plus 1. So let's go ahead and get started and define our function. All right, so I'm going to define a function f of n, and this is going to be equal to a summation because a for loop can be represented as a summation. So we have our first summation, our outer summation, and we have our outer for loop, which runs from I equals 1 to n times n, and that's just n squared. So we're going to have a summation that runs from I equals 1 to n squared. Okay, and within that for loop, we have another for loop, so we're going to have another summation within this summation here, and that inner for loop runs from j equals 1 all the way up to I times I, which is just I cubed. So this summation is going to run from j equals 1 to I cubed. And within that for loop, we have our statement y equals y plus 1, which runs a constant amount of time. So I'm going to put a 1 here for our constant. All right, so now we just need to solve this summation, or both of these summations. And we can use a nice formula here. So I'll write it down here below. And the formula that we're going to use says that if we have a summation that runs from I equals 1 to n of 1, then we get just n. So we're going to use this formula here to solve our first, or I'm sorry, not our first, but our inner summation. All right, so we're going to try to solve this summation here using the formula down below here. All right, so what we need to do is we see that we can replace our j value here for the I value down here in the formula, or vice versa, and we can replace the I cubed variable for our n variable here, and everything else is the same. So that means that our function is just going to equal whatever that variable on top of the summation is. So now let's rewrite our function. So we still have the summation from I equals 1 to n squared, but now we're going to have I cubed. And again, that's just because we're simply replacing the n value here with our I cubed value. Okay, so now what does this equal? Well, let's try to solve this summation now using another formula. So I'm going to write the formula down here. I'm just going to call it formula number 2. And it states that if we have a summation from I equals 1 to n of I cubed, then this is equal to n to the 4th divided by 4 plus n cubed divided by 2 plus n squared divided by 4. Okay? So we're going to use this formula here. So now let's rewrite our summation. So we have, instead of n, we have n squared. So we're going to have n squared to the fourth divided by 4 plus n squared to the third divided by 2 plus n squared to the power of 2 divided by 4. All right, and what you can see is all we did was replace the n variable in the formula with n squared. Okay. All right. So what does this equal? Probably, let's see, n squared to the power of 4 is just equal to n to the 8th power. So we have n to the 8th divided by 4 plus n squared to the power of 3 is just n to the 6th divided by 2 plus n squared to the power of 2 is just n to the power of 4 divided by 4. And I'm going to erase our formula down here. All right, just so I can make some more room with this simplification. Okay, so now what this equals is n to the 8th plus 2n to the 6th plus n to the 4th, all divided by 4. And all I did was I just changed the problem here, which is n to the power of 6 divided by 2. It becomes 2 times n to the 6th divided by 4. Okay, so that's equivalent. They're still equivalent. And so that's what I used here. So I can get them all under the same denominator. All right. So now this tells us that this function belongs to big O of n to the 8th power. And our statement y equals y plus 1 is executed n to the 8th plus 2 n to the 6th plus n to the 4th, all divided by 4. And its big O representation is big O of n to the 8th power. So that's basically it, guys. This is the answer. Thank you for watching. Please leave any questions you have in the comment section. Don't forget to hit that like button and the subscribe button. If you found this video helpful, please share it, and maybe others can find it helpful as well. And as always, guys, thanks for watching, and I'll see you all in the next video.